More wrinkles which the AP writers like to throw in is, what if instead of you finding the value of the definite integral, they give you the value of the definite integral, but they throw an extra variable inside the integral itself and ask you to solve for that variable. That's what's happening with these examples behind me. In number 9, we see that our function is 2x minus k. All right, that's our integrand, and the whole value of the definite integral is 12. And they want to know what's the value of k. Well, you're going to solve this as you normally would, antiderive, plug in your bounds. The only difference is then you'll have an equation in which the only variable will be k, so you can solve for k. That same thing's going to happen over here in example 10, except this time k is one of the bounds. It's a little more complicated, but overall these problems are the same idea as a regular definite integral. So let's go ahead and attack them. With number 9, we need to take the antiderivative of 2x minus k. Well, 2x antiderives 2x squared, and k, that's a constant. So it's like a 3 or a 5. So when we antiderive it, it becomes kx, because the antiderivative of 3 would be 3x. So the antiderivative of k is just kx. Right? And that's being evaluated from 0 to 1, and it's still equal to 12. Okay. Now we're going to work the fundamental theorem of calculus. We're going to plug in the 1 and the 0. When we plug in 1, we have 1 minus k times 1. When we plug in 0, we just have 0. Okay? And that's equal to 12. So we can see here that 1 minus k is equal to 12, which means that if we do a little, whether you want to add k to both sides and then subtract 12, or you just do your mental math here, 1 minus what number is 12, our answer is going to be negative 11. K equals negative 11. Right. Over with example 10, same idea. Take our antiderivative. So 4x antiderives into 2x squared. 8 becomes 8x. And this is going to be evaluated from 1 to k, where the answer is negative 2. We're going to plug the k in first. So we have 2k squared minus 8k. And then we're going to plug in the 1 next. So we're subtracting. Now we plug in the 1. When we plug in 1 here, we get 2. When we plug in 1 there, we get 8. So we have 2 minus 8. And again, that's equal to negative 2. Now we have an equation. There's only one variable in it, k, so we want to solve for that. We see that k is a quadratic. So we know that with a quadratic, we want to set that equal to 0 so we can factor it into a couple of binomials. So let's go ahead and do that. We have 2k squared minus 8k. This is going to be negative 6 right here, so we are adding 6, but we also have to add 2 to both sides. So we have minus negative 6, which means plus 6, plus 2, so that's actually plus 8, and we're equal to 0. Okay, so what we have here is a quadratic. Every single term is even. Let's pull out a 2. So we have 2 times the quantity, k squared minus 4k plus 4 is equal to 0. And now with this quadratic, we have a leading coefficient of 1, which means we're looking for two numbers which multiply to the c term, the 4, and add up to the b term, the negative 4. What are two numbers that multiply to 4 and add to negative 4? Yeah, negative 2 and negative 2. So we have here is 2 times k minus 2 times k minus 2 is equal to 0. And again, if we FOIL these two binomials, we'll get this trinomial. All right? What values of k make this true? Well, we can see that 2 is the only answer that works out. So k is equal to 2.